Hi, in this video, we're going to learn how to graph logarithmic functions. Those will look like f of x equals log base b of x. Now, one of the interesting things about logarithmic functions is that you can only plug positive values into them. So that means that you can't plug in a negative and you can't plug in a zero. So the first part of graphing these is to first draw a vertical asymptote at x equals 0, because you can't touch x equals 0 and you can't go to the left of it. The next thing you're going to do is plot the point 1, 0. This is going to be the point no matter what type of logarithm you have, because log base b of 1 will always equal 0. The next thing you'll do is plot the point b1, where b is the base of the logarithm. That's because log base b of b equals 1. Then you're going to plot b squared 2, because log base b of b squared is 2. And that's using the fact that when you have an exponent and the base and the inside match, you get to keep just the exponent. Once you have a few points in that asymptote, you're going to be able to connect the dots. Just don't forget to put arrows on the ends of your curve to show that it will continue in both directions. Let's take a look at this example. If I have log base 2 of x, the first thing I want to do is graph that vertical asymptote at x equals 0. Notice that I draw this with a dotted line because it represents an asymptote, which means I will not touch it. All right, now I'm going to plot some points. So remember, the first point I will always plot is 1, 0. So that is what that looks like. Ta-da! Then I need to plot another point. This one is going to be the point B1. All right. Now our base in this case is 2, so it's the point 2, 1. Now I'm going to plot b squared 1, b squared 2, which means that I'm going to have b squared in this case is 2 squared, or 4. All right, so this becomes 4, 2. And now that I have my 3 points, I'll be able to connect the dots in order to complete my graph. And this is what that will look like. Notice that we curve the graph so it goes along the asymptote without touching it. But what if we have a horizontal shift, you might ask? So that might look something like this. F of x equals log base b of x minus a. Well, now, which value of x would make the inside of the logarithm equal 0? Well, that's going to be a. If I plugged in a, I'd have 0, which is not allowed. So now our vertical asymptote has shifted a away. So in this case, x equals a is my vertical asymptote. I've moved to the right a units. This means all of my points have shifted as well. So now instead of plotting 1, 0, I'm going to plot 1 plus a, 0. Okay, and notice that's because when I plug in 1 plus a into the logarithm, that's 1 plus a minus a, which is just 1. And that's that log base b of 1 equals 0. So what happens is we actually are shifting every point a to the right because a is a positive value. All right, so then I have b plus a, 1, and b squared plus a, 2. Now I can complete this graph by connecting the dots. Let's take a look at this shifted example. Let's say I gave you log base 3 of x plus 2. The first thing you have to recognize here is that this is actually a leftward shift, because when we were looking at the format where I had x minus a was a positive number, right? Well, now I have x plus 2. That's really x minus negative 2. So I have x equals negative 2 is my vertical asymptote. So again, notice here, a is negative 2. Another way to think about it is what makes the inside of the parentheses equal to 0. So now that I know that, I'm going to figure out what my next point I can plot is. Remember, it's normally 1, 0, but now I'm going to shift it by a, which again is negative 2. So that's 1 minus 2, 0, or negative 1, 0. I can plot that point. Now the next point I'm going to plot is going to be b plus a, and then 1. All right, so my b in this case is 3, because that's the base of my logarithm. Again, my a is negative 2. So 3 minus 2 gives me 1, 1 as my point. Last point we need to plot is going to be our b squared plus a, comma 2. And again, our b is 3, so this is 3 squared minus 2, or 7 And then again, the y value is 2. So I plot 7, 2 here, and I go ahead and connect all of my dots to complete the graph. And that's going to give me this graph of the logarithmic function. So even if there's a horizontal shift, it's still the same setup. All right, that is how you graph logarithmic functions.